Alright, welcome everyone to our channel. Today we're going to be talking about kinematics. So, kinematics. And now kinematics is just the study of anything that's moving. So, study of an object or objects moving. Just a fancy name for it. Now, in most kinematics that we're going to be talking about in non-calculus physics, we're going to assume that the acceleration is constant and the following formulas are going to become your best friends, and I will suggest you to memorize them for your test, or if your professor allows you a cheat sheet, write them down, because it's guaranteed that you will have at least one problem involving them. So now the following formulas: x equals to x naught plus v naught t plus 1 over 2 at squared. Now remember, the naught just means initial and the regular is just final. Then v equals to v naught plus at, v squared equals to v naught squared plus 2a, change on x, and remember from our previous videos, change on x just means final minus initial, and v average is equals to v plus v initial over 2. Remember, all of these formulas assume constant acceleration. So A is constant. Okay, now I'm going to work an example out, and it's actually going to be about free fall. So I'm covering two topics in one video. So now, moving on to our next topic, free fall. And let's suppose you have a building an apartment complex or anything, and you stick out a box out of the window and you drop it, you let it fall. So of course your box is going to move downward till it hits the ground, and let's say you left it fall at a distance of 10 meters. The initial height was 10 meters. Now, and the problem I ask you, find time it took the box to fall. Now what you're going to do there, it's because on Earth we have constant acceleration, which is gravity, negative 9.8, because it's going downwards. We are going to say, okay, which of these formulas can we use? We don't have velocity, and that doesn't have time. We're interested in time. V squared equals to v naught squared. That doesn't have time either. So now that only leaves us with the first two. And now, do we have velocities? We don't know the velocities. We do know the acceleration. As we said, in gravity, for free fall, it's going to be negative 9.8 or negative g. And now, so that leaves us with x equals to x naught plus v naught t plus 1/2 at squared. So let's go ahead and use that equation, because interestingly enough, you will realize soon that that is the equation you will always use for free falls. So we're going to say x equals to x naught plus v naught t plus 1 over 2 at squared. Now let's find our variables. The initial height was 10 meters, and our final height is the ground, which ground is usually 0 meters. Okay, so now this right here goes to 0. Now what was the initial velocity it had at time 0, or at our initial time? The initial velocity, I correct myself, not time 0, just over the time it traveled, but the initial velocity itself before we let it go was 0 meters per second. So this also becomes a 0. So then we're just left with 0 equals to x naught plus 1 over 2 at squared. And here we just have to rearrange to find t. So we move this to the other side. This is just a little bit of algebra, so if it's confusing and you'd like me to explain it, please request it. So now rearrange, move the 2, so negative 2x naught over a equals to t squared. And now this a, we already know it. Remember we said in Earth, a is always equals to negative g, because g is always acting on any object, and the negative because it's going downward. So now we're going to say negative g, so the negatives cancel out, and you end up having 2x naught over g equals to time squared. Now just to find the time, take the square root on both sides, and you end up having t is equals to the square root of 2 times your initial height divided by g. That is for this case. So now let's go ahead and plug it in. And now we're going to say, all right, t is 2 times our initial height, which we said was 10 meters. So 10 meters over gravity, which we know is 9.8 meters per second squared. Notice how the negative gravity cancel out from the negative position earlier. So now meters cancel out, and you end up having divided by the inverse, divided by second squared, so you end up putting it on top and then taking the square root for units. So here, after you plug this into your calculator, you end up having 1.43 seconds. So it took the box 1.43 seconds in order to fall, and that is your answer. I hope this video was helpful. Remember to like us on Facebook and subscribe on YouTube, and leave us any comments. Good luck in your studies.